Today we're going to look at geometric series. We want you to be able to find the sum of a geometric series and find the sums using that sigma notation we talked about in the last one. The first problem here is a situation maybe you've run into. It says, suppose you email a joke to 3 friends on Monday. Each of those friends sends a joke to 3 of their friends on Tuesday. Each person receives that joke, sends it to 3 more people, and so on. How many people have read it by Friday? So this type of situation, we could find out maybe like making a table here. So we got Monday, Tuesday, Wednesday, Thursday, and Friday. And we know we start with 3. Each of those friends passes it on to 3 more. So if each person has 3, 3, and 3, that means we're up to 9. If each of those sends it on to 3 more, now we're at 27. And you can kind of see our little pattern here. It looks like we're multiplying by 3 each time to get the next one. So if you take 27 times 3, it's going to be 81. Times 3 again, that'd be 243. But now we got to answer the question, how many people have read it by Friday? Well, 243 is not the answer. That's just how many new people receive that. So to figure out the total number of people, we want to find a series. And what we talked about on the last one is that is taking your sequence, adding up all the values to find the sum. So if we add all these up, we would get a total number of people here that read it to be 363 people. All right, well, that works out pretty good making a table on this one. But what if it had said how many people have read it in 100 days? We won't want to sit here making this table out to 100 and figure it all out and then sit on our calculator and add up 100 numbers. That's not very efficient. So we want other ways of doing this problem. And we can do that with some formulas here. So there's 2 geometric series formulas we can use. And a lot of these terms mean the same thing. S is going to mean the sum. This is the first term. R is that common ratio. N's the number of times or terms that you're doing it. And then in this formula, A sub n, that's the last term. Okay, so we want to be able to do these either way. We could do that last problem with one of these formulas. So if we take the information we know, such as the first term, there's 3 people that know it. Each time we said it's multiplying by 3, so here our common ratio was 3. And from Monday to Friday, that means 5 days. So if we take this first equation here, and use that, we should be able to find out the same answer using the formula. So here the sum would be the first term 3, 1 minus our ratio of 3 to the 5th power, all over 1 minus 3. When you simplify these, make sure you start with parentheses here. So in the parentheses part, you probably want to do like on your calculator here, 1 minus 3 to the 5th power is negative 242. And now if we times that by 3 and divide by negative 2, we should get the same answer. Times 3 divided by negative 2. Yep, 363. So this is another way that you can get the same answer. And this one would be a lot better, especially if it had said like 100 people, because this would be much bigger. Okay, these types of situations, when you're talking about like Twitter or something, that's where something goes viral. It expands very rapidly and gets huge. All right, so let's look at number 1. Find the sum of a geometric series for which the first term is 1,000, the last term is 125, and R is 1/2. This one, because we know the last term, looks like this second formula would be the better one to use for this one. So substituting in the information we know, 1,000 minus the last term is 125 times R of 1/2 all over 1 minus 1/2. Well, simplifying here, we want to make sure we multiply before we subtract here. So 1,000 minus 1/2 of 125 is going to be 62.5. And then on bottom, 1 minus 1/2 is going to be 1/2. We want to subtract this now. before we divide so that we simplify both numerator and denominator. So that's going to be 937.5 divided by a half. And if you divide that out, that should give us our total. And it ends up that it's 1,875 would be the sum of all the terms of this series. All right, let's look at another one. Maria arranges some rows of dominoes so that she knocks over the first one. Each domino knocks over 2 more when it falls, and so on. If there are 10 rows, how many dominoes does Maria use? So maybe some of you as a kid kind of set this up and knocked them over and you see how the dominoes fall. Well, we want to see what information do we know. The first row has only 1 domino, so the first term is 1. Each domino knocks over 2 more. That means our ratio here is 2. There's 10 total rows, meaning our n is 10. So now we want to see which one works better. Well, we don't know what the last term is. That wouldn't be the good equation to use. Looks like we want to select that one. So our sum is going to be 1 times 1 minus 2 to the 10th power all over 1 minus 2. Simplifying that, our bottom is going to be -1. Let's use our calculator again to see what the parentheses are going to be. Looks like we get -1023. Well, if we times that by 1, it's still the same number. Divided by -1 would make this positive 1023. So it would take 1,000 dominoes to set up these 10 rows. Over 1,000 dominoes. All right, number 3. Contagious diseases can spread very quickly. Suppose 5 people are ill during the first week of an epidemic, and each person who is ill spreads the disease to 4 people by the end of the next week. How many, or by the end of the 10th week of the epidemic, how many people have been affected by this illness? An epidemic is something where a disease spreads very quickly. Why don't you pause the video, see if you can pick out the important information and set up and solve this problem. All right, let's see how you did. The important information here, 5 people start with it, so A1 is 5 here. Each person spreads it to 4 new people, R is 4. How many people have been affected by the end of the 10th week? N is 10. This would be the one we want to use again because we know information to fill that in. So you'd have 5 times 1 minus 4 to the 10th power, all over 1 minus 4. Simplifying that, make sure you do parentheses first here. Bottom is going to be -3. If you put that in your calculator, it's going to be quite a big number, I think. Yeah, it looks like we're in the millions here already here, -10. Okay, next, make sure you multiply and then divide. So times this by 5, divide by -3. And it looks like after 10 weeks here, this is in the millions of people. And that's why diseases that can spread quickly are taken very seriously. There's World Health Organizations that monitor this type of stuff, make sure there's no outbreaks or epidemics that happen. All right. The other way we want you to be able to do this is with that sigma notation that we looked at before. Remember the sigma notation, this Greek letter sigma means sum. We're finding the sum. This is the starting value, this is the ending value, and this is the expression used for generating the terms in the sequence. So number 4, they want us to figure out what is this going to equal. 2 ways you can do it again. One would just be to find each individual term and add them up. So on number 4, if we started with 1, a sub 1 would be what we get when we plug 1 in for this. Well, 3 to the first power is 3 times 2 would be 6. A sub 2 here would be same thing, just squared. So 3 squared is 9. 9 times 2 is 18. The third term, now we got 3 to the third power, which would be 27 times 2 is 54. And you can see that there is a pattern to this. Each time it looks like we're timesing by 3 here to get to the next one. So if you took 54 and multiplied by 3, you'd get 162. And the fifth term, if you multiply that by 3, we would get 486. And we want to stop there because that's our top number. So then the sum of this would be adding all those up. So if we add 6 plus 18 plus 54 plus 162 plus 486, you would get the summation of these, which does turn out to be 726. And that would be the answer to the problem. So if it's a small one like this, there's nothing wrong with going through and doing the problem like that. However, what if this top number had been bigger? What if it was 500? We wouldn't want to sit here finding 500 numbers and then typing 500 numbers in our calculator to add them up. So again, if you notice that this is a geometric series, and this one would be because this has that form of y equals ab to the x that we've talked about, you can use one of these formulas to do it again. Okay, in this case, it looks like a good one to use might be like this first equation over here, because we know some of the information that we need to put in there. N would be the number of terms here. The number of terms is 5. There's 1, 2, 3, 4, 5 terms. Now be careful again, like we talked about with arithmetic. If it's not 1 at the bottom and it's a different thing, if you just subtract these two numbers, 1 and 5, you don't get the number of terms, you get 4. You always got to add 1 on to count the starting one. So N is going to be 5 here. The common ratio, what it's increasing by is 3. It's timesing by 3. That's this number here. So R would be 3. And then the first term you'd have to plug in and calculate is 6. So now put those into this summation equation. We should get the same thing. S would be the first term 6. 1 minus 3 to the 5th. All over 1 minus 3. Solving this out. Let's use calculator again to find the parentheses. 1 minus 3 to the 5th. It's negative 242. Times that by 6 and divide by negative 2, and we should get the same answer. And it looks like we do. 726 is the same thing we got before. So you can use the equations to do these as well. Let's try one more here. Number 5, what is the summation of this one? Now here you got to be careful. This part is a geometric one because it has the form we talked about here. A would be 1 since there's no number in front. B would be 5, and there's an exponent. But the plus 7's part is what changes this one. Having that plus 7 there, that one makes makes this not a geometric or arithmetic one. So on one like this, you wouldn't be able to use either the equations we had on the last notes or these ones. So you would have to actually just go through and find these terms and add them up here. So on this one, we'd want to find what is the first, second, third, and fourth terms here, and then find the sum of those. So the first term, if we plug 1 in here, we'd get 5 to the first power plus 7, which should be 12. Plug 2 in, we get 5 squared plus 7. 5 squared is 25, plus 7 would be 32. Next one, 5 to the third power plus 7. 5 to the third power is 125, plus 7 would be 132. And then 5 to the fourth power plus 7. I'm going to use a calculator for that one. Let's see, 5 to the fourth plus 7 is 632. So then the sum of these would be adding this up. And if you add all those up, you would get a total of 808. So summation, if you have an arithmetic or geometric one, you can use the formulas. If not, then you would have to actually go through and add those up. All right, you try them out now on the practice.